An update for the new Australian standards AS/NZS 62676 video surveillance for use in security applications. A bit about myself: I've been an integrator, manufacturer's representative and consultant for over a 30-year period. I've been a state chairman and director of ASIAL and been on several advisory councils over this period as well. I have been recognised as a fellow of the Australian Security Industry Association and am a member of ASIS International. I've been delivering stakeholder training to local government for over 10 years and creating courseware and delivering specialised industry training for RTOs over 12 years. I've been conducting executive briefings at the National Security Conference and Exhibition on CCTV design and integration for the past 4 years, including providing briefings on the applicable changes relating to the implementation of the new standards for over 18 months. I've also been supplying training and technical documentation packages to local government organisations and federal agencies such as the police on the new standards and their implementation. We'll be discussing the withdrawal of AS 4806 and the adoption of the new standards during today, including some of the changes based on the new standards for surveillance systems for use in security applications and some of the overriding considerations. Owing to the volume of changes and time restrictions, we can't cover everything, unfortunately. So we do offer detailed training via webinar or in person to local government through LG Pro, as well as offering small group sessions at your local premises. So, AS 4806, why did it have to go? The old Australian standards relating to closed circuit television were written approximately 2003 and adopted in 2006. So, over that period of time, which is some 17 years, we've seen a whole raft of changes. The introduction of network or IP-based cameras, introduction of high-resolution and megapixel cameras, global deployment of cheap IP network infrastructure, and a rapid growth of cybersecurity issues, such as penetrations leading to compromised networks as well. The old standard didn't cater for any of that. The old AS 4806 was based on analogue systems running coaxial cable between the cameras with a maximum resolution of 400 TV lines. So the new standards, or adoption thereof, made sense to assist organisations to standardise the equipment and outcomes to suit modern deployments, guarantee interoperability between remote devices and head-end equipment, and assist in securing and aspects relation to communications infrastructure, which is central to what we do today. The graph on the right hand side shows penetrations in relation to cybercrime as reported last year in Australia. So in June of 2019, the Australian Security Industry Association, or ASIAL as we know it, submitted a proposal to Standards Australia through the EL31 Electronics Committee to formally withdraw AS 4806 as they were no longer current. This paved the way for the adoption of the new Australian standards for CCTV to be released, and this was completed on the 24th of April 2020. It took many years to bring these standards to fruition, and as such there have already been some changes we've seen implemented, and that withheld one of the standards from being released at the time, although it should be promulgated in the next week or two. The new Australian standard is AS/NZS 62676:2020, video surveillance for use in security applications. It should be noted that the old ANSPAR standard was benchmarked against the old AS 4806 series, and as such no longer comply with the requirements of the new standards. The new standards are comprised of several parts. Part 1.1, General System Requirements. 1.2, Performance Requirements for Video Transmission. 2.1, Video Transmission Protocols General Requirements. 2.2, IP interoperability based on HTTP and REST services. 2.3, IP interoperability implementation based on web services, and this is where ONVIV comes in, which we'll cover on the next couple of slides. Part 3, Analog and Digital Interfaces. Part 4, Application Guidelines. Part 5, Data Specifications and Image Quality Performance for Camera Devices. ONVIV. ONVIV is a standardised interface for interoperability of IP-based physical security products. It was a foundation that was set up in the early 2000s by Sony, Access and Bosch, and now has grown to include several hundred manufacturers as well as end users and other member groups. The benefits to end users for using ONVIV compliant equipment: it eliminates compatibility problems, provides greater flexibility, allows you an increased product choice knowing that you won't have any intercommunication problems, and future-proofs your systems moving forward. ONVIV gives you the ability to pick and choose optimal products for your needs without being locked into specific brands. An ONVIV conformant video management system, for example, will allow you to integrate ONVIV conformant devices from different hardware manufacturers without the need for specialised drivers or programming. The ONVIV specifications for network have been included in the early IEC 62676 standards from back in 2013, and now they've been adopted in full as AS/NZS 62676:2020. It should be noted that the IEC standard was the first international standard for video surveillance to be established. So Part 2-3 defines video transmission protocols for communication between network video clients and video transmitter devices, for example cameras and head-ends. Conformance to profiles is the only way that ensures compatibility between ONVIV conformant products. Therefore, only registered products with conformance to a profile are considered to be conformant. There's a link following that statement at the bottom of the page which will take you to the ONVIV conformant products aspect of their website. So, what is an ONVIV conformant product? To be able to comply with conformance, manufacturers must be able to implement all mandatory and applicable conditional features for the claim profiles, as they are listed in the ONVIV profile specification documents. They've got to respect the entirety of the specification and the methods described in the ONVIV network interface specification set documents, as well as the corresponding WSDL and schema specifications. This includes optimal functionalities not listed as mandatory in the claim profiles. They've got to positively respond to the test routines of the ONVIV test specification documents corresponding to whatever profile they're claiming. And they have to pass the ONVIV device test tool and the ONVIV client test tool for the claim profiles. They then have to submit the declaration of conformance to the open ONVIV interface guide and feature list file through the ONVIV member portal. As such, documents for ONVIV conformant products are accessible by finding the product on the conformance products page. Please note, products may use ONVIV standards, but they can't claim to be ONVIV profile compliant without completing the conformance product process. Why is that important? ONVIV membership is open to everyone, any company, observer, user, contributing or full membership. However, if a company is listed on the US Administration Regulations entity list, they are subject to the following membership restrictions: no access to member-only information, including the online member portal, so they can't submit their products for compliance; no participation in ONVIV committees, including profile development, maintenance or other internal workshops. Companies on the entity list can continue to submit products for conformance based on the version of the test tool available to them at the time they were placed on that entity list. Once a new version of the test tool is required, however, for ONVIV conformance, the affected companies can no longer submit products for conformance. For more information on the test tool, they are typically updated once every couple of months. So conformance to profiles is the only way that ensures compatibility between ONVIV conformant products. Therefore, only registered products with conformance to a profile are considered to be ONVIV conformant. This means if you have a company that's placed on the banned entity list in January, for instance, they may have access to the current test tool, which might be still in process till March. A new test tool is released in April. They can only test their equipment to what the test tool was at the time they were put on the banned entity list. As a new test tool is released, they can no longer test their equipment or any firmware upgrades to their equipment for compliance with the new test tool. So that way a conformant product will become out of date very quickly, particularly if they need to do firmware updates to comply with upgraded test tool requirements. There are several major manufacturers on the banned entity list, I would urge you to go to the link, download the list, and look for the manufacturers of the cameras and equipment you're using on that banned entity list. And it should also be noted that there's some Chinese companies out there that produce cameras for about 100 other organisations under what we call an OEM or original equipment manufacturer banner. Because they are producing the cameras, they have to conform to ONVIV, and if they are on the banned entity list and they can't use the conformance tools or submit the documentation for conformance, all those manufacturers they produce cameras for can no longer be conformant with ONVIV either. It is extremely important that if you are purchasing cameras, you know their source of manufacturer and you're able to verify conformance to the ONVIV profile to comply with the standard. ASNZS looks at the way video surveillance systems operate from a whole process, not from just the camera or recorder, but takes into account all aspects of functionality, including justification for putting the equipment in. The definition of a video surveillance system as per ASNZS 62676 is: a video surveillance system is a combination of image capture devices, lighting, interconnection, image handling devices, etc., selected and installed to meet customers' security surveillance requirements. As part of the new standard, it also says, prior to the video surveillance system design and to help understanding its purpose, a threat assessment and risk analysis should be performed. The threats and hazards to the premise should be identified and assessed for their likelihood and impact. These represent the risk to the premises or organisation. The results of the risk assessment should be used to determine the requirements of the video surveillance system and its components. So where appropriate, a security grade should be assigned to the components, subsystems, and functions of the video surveillance system. Identified security grade requirements should be specified in the operational requirement, or the functional outcomes as we call it, and agreed to by both the customer and the system designer at the outset. So areas covered under the standard include not only the camera imaging and resolution, but defining the operational requirements, risk assessments, grading of the systems, equipment selection and performance, image presentation, transmission, video performance, storage characteristics, image storage and export, control room configurations, test planning, pre-installation documentation, system installation and commissioning, final design and maintenance. The first four areas that are highlighted are what we are going to lightly touch on this morning. Identifying outcomes, or defining your operational requirements. You need to create a functional outcomes document for the project. The operational requirements document should be a formal written statement of need, including the justification and purpose for the proposed video surveillance system. The process should include a site review prior to the production of the operational requirements, and should provide in-depth detailed requirements as to how the system is to operate, where or when it's to be used, and the purposes of the installation. It also needs to clearly delineate who is intended to use it and what information needs to be generated. So examples of some things typically, if you look across the bottom of the screen on the left-hand side, you've got a camera looking at a road. It's all very well and good if you want to see the road nice and clear, but it seems pretty pointless putting a camera in that you can't pick up the number plate of a vehicle if that was the outcome. Likewise, on the right hand side you see an entryway. How many times do you walk into a building or you see a camera's view where someone comes into a building and you see the top of their hat or the bald spot on their head? You need to be installing cameras so you're able to use the outcomes in a functional way, and that means get identification if required from people accessing the premises. Assessing the risk, confirming the validity of your operational requirements. The threat, vulnerability and risk assessment is used not only to determine the appropriate level of coverage designed to mitigate the assessed risk, but also to validate the perceived requirement for coverage within an area to meet the required outcomes. Although ISO 31000 describes the principles for carrying out a risk assessment, it's highly recommended that persons completing these assessments have a demonstrated high-level expertise in conducting security-based risk assessments. The standard risk assessment course that you do online does not go into the level of detail quite frequently you need to consider when we're talking about video surveillance system or security-based risk. Some other examples of issues to be considered, and this is only a very cut down list: historical information, speak to the police, the stakeholders, find out what history has been there in the past, the cost of lost experience or what may be lost in the event something is taken, locations of the positions of the equipment within the premise in relation to the socio-demographic and so forth, occupancy, who's using it. You might find you have higher risk groups using the premise at different hours to other groups, which means that your threat assessment may change depending on the situation. Usage, interaction with other groups, to name a few. While this frequently stops money being thrown at a perceived risk without justification, if done, it should also identify other vulnerabilities as it accounts for the whole site and accounts for its usage as a whole. Under the new standards, we actually grade the functionality of our CCTV systems. So there are 4 grades. Grade 1 is the lowest and it goes up from there. Grading of the CCTV system is not the same as with intruder detection, so there are differences there, please understand. The standards allow for flexibility, but it's recommended that system designers should choose the simplest approach that will work, ideally 1 grade applied through the whole system. Grading will affect the protection level and restriction of access to the system. Grading of the system does not determine the quality of the images captured by the system elements, such as image quality, screen occupation, and similar specified under Part 4, which is the application notes. But how these need to be clearly defined under all operational conditions, not just through daylight. The chosen grade should be recorded in the operational notes. It needs to include the functions of the CCTV system and the NVR that you're requiring from it. So when we're looking at a network video recorder or a video surveillance system, we're looking at the functionality of that system. The standard permits the grading to be divided up by function, and as such there's 18 functions you'll see in the next couple of pages on the tables. Additional flexibility can be obtained by documenting specific requirements in the operational requirements or the system design proposal. Typically each function will have a consistent grade throughout the whole system. Grading of the system includes several components that we typically have never considered before. So the following video surveillance system functions are taken into account by the grading process: common interconnections, storage, archival and backup, alarm related information, system logs, backup and restore of system data, repetitive fail notifications, image handling device power supply unit monitoring, image buffer holding time, essential function device failure notification times, monitoring of interconnections, tamper detection, authorization code requirements, time synchronization, data authentication, export copy authentication, and data manipulation protection. So this is an example of a table which was produced by the British Security Industry Association, and it actually shows pictorially how the grading applies to the different functions against the different grades of systems. So there's 3 pages in relation to that, and it goes through each of those relevant grading criteria, and as you can see, depending on what level of functionality you require will affect the system grade as an overall concern. In summary, the new standards will allow you to address the needs of your organisation and make sure they're properly specified and understood. To make sure the system is designed, installed and operated and maintained to meet the organisational needs, to enable an easy comparison between your tendered proposals you have coming back in, enable a consistent application of feature sets across the organisation, and provide a simplified method for specifying a system with easy reconciliation of the responses you receive. Equipment selection. Under the new standards, we require the lens and the camera combination to be selected such that the measured visual resolution that you determine from your field of view and its low light performance are capable of filling the requirements as defined by your operational outcomes. This means that if you need a camera to pick up someone walking across a car park at night time, the camera has to have the ability to work within the light constraints for the area. It needs to be able to have the right resolution on the target. If you want to get ID, you need to have the right amount of pixels per meter physically on target to give you that resolution. And it doesn't deliver motion blur when the person is walking. Likewise, if you've got a car going down the road, you need the camera to be set up to work effectively with that vehicle at night time, so that it's not blurry, it is in focus and you're able to determine license plates, for example, of the vehicle as it's going down the road. This should all be defined for each camera within your defined outcomes. If you look at the pictures across the bottom of the screen, you'll see two resolution charts, one based on 61 pixels per meter and one based on 303 pixels per meter. So as you can see there, the higher those pixels per meter, the more resolution you're physically going to get on target. You need also to understand that camera resolutions are not the same day and night. The resolution of the camera's putting out may be the same, but the performance and the way it handles the image capture under different lighting conditions will affect the way that pictures are displayed. So in relation to the outcomes that are there, you'll see that the daytime outcomes are very different to the nighttime outcomes, and as such your cameras need to be tested at night time to make sure you can still get the relevant organisational requirements met for them even in low light scenarios. Other things we look at in relation to camera performance is the white balance. If we're using some left of centre light, we might need to correct it. Dynamic range or the noise of the sensor, the relevant data and protection, relevant prevention of motion or movement blur owing to long exposure times. Again, if you look at the vehicles on the bottom left of the screen, two cameras, 10 o'clock at night, no light, vehicle travelling 50 kilometres an hour. Camera on the left is a pretty good picture. You can see the spokes on the wheel. Camera on the right, not very good. You can't see the wheels clearly. The shutters are held open too long to try and give it that low light performance, and as such you don't get the right outcomes. If you equate that to something like National Geographic, where you see a vehicle going down a highway at night time and you see the trail of lights going down the freeway, exactly the same sort of thing happens. They hold the shutters open too long to let more light in, which gives you a good static picture, but motion is not picked up very well. So when we're talking about the spectral sensitivity in relation to the types of illumination used, if you change lighting from high pressure sodium to LED, you may find that the cameras won't work as well. You need to make sure the cameras are sensitive to the imaging or the lighting systems that you're using for your imaging component. Provisions for external synchronization, such as line lock and time. Quite frequently we see the camera time not correct, and as such it's recording in the wrong time frame on the network video recorder. So it's important you synchronize all your times together for all your devices within your video surveillance network. Provisions for remote calibration of imaging devices and backup power supplies. Remembering when we're talking about IP or network based devices, these things might go across a long distance, and as such they might pass between 2 or 3 switches to get back to the head-end equipment. If you have a loss of power in any one of those switches, you lose the ability to get the information back to your monitoring point. So your backup power needs to be considered for your network as a whole, not simply your camera and just recorder. When we're viewing cameras on screens, again, a lot of the standards that are out there tend to talk about forensic minimums. You need to consider functional requirements. So it's not much point having an image that's so small on screen that it works forensically. You need to take into account how an operator is going to use it. And you need to be aware that if you put a very high resolution monitor on your system and your cameras aren't of the same resolution, your pictures are going to be smaller, such as on the bottom left hand side where you might have a 4CF standard def camera from the old AS4806 series days, and you're trying to bring that into a new 8K monitor. The pictures become too small to see. So that's where the table comes in, and it shows based on a person's screen height in percentage. So if we're using a 1080p camera and we want to identify someone, we want that person to take up about 40% of a 1080p monitor. So that gives you an idea of the percentage in screen height which we're trying to achieve for the different levels. When we're talking about transmission considerations, interoperability of video transmissions, stream control, eventing, discovery, description of network devices based on one framework, integrated needs to set a high level video protocol. So with AS/NZS 62676-2-3 based on web services, it includes the ONVIV specification requirements, which are mentioned over 1400 times in 1200 pages of that particular part. These are not small documents. ONVIV takes into account specification overview, web service framework, IP configuration, device discovery, device management, device I/O, display, imaging and media, real-time streaming, event handling, pan-tilt zoom control, video analytics, defining the ONVIV analytics model, video analytics devices, defining the commands to deal with the analytics device, recording, search and replay control, and security selection for the transport of the messaging level security requirements for an ONVIV compliant implementation. Very briefly, we've covered the first 4 aspects of what the standards talk about: defining the operational requirements, risk assessments, grading systems, and equipment selection and performance. The other aspects are all mentioned within standards, and as such your documentation needs to be complete, clear and precise as to your required outcomes, not only for your CCTV system but for the whole installation process. If you've got any questions, can you please forward them through and we can get those answered for you as soon as we receive them. Thank you very much. The thing to remember is the new standards are a parity shift to what we've ever been experienced to in the past. They go a long way to solving all the issues we've had typically with installations on client sites, but there's still room for improvement, as there always is. So they're a good guideline to use to give you a base level when you're going in and doing specification or you're designing systems now in relation to the CCTV aspect. It should be noticed also that the new Australian standards for access control also encompass the same sort of risk matrix and risk assessment requirements in a similar way to what the new CCTV standards actually employ as well, and they're also adopting ONVIV within the new access control standards. If anyone wants further training or stakeholder training on the technology behind CCTV or anything these days, we do offer that. So please give ASIAL a call and we can organise to catch up with you separately and tell you what can be available. Due to the present industry training, CIPSEC 2023, okay, it's important to note the current training portfolio for the CIPSEC modules have been referencing AS2201 for the past 10 years. The relevant bodies that were responsible for the CIPSEC modules have been contacted to get that rectified. As late as a couple of days ago, ASIAL actually went back to Artibus in relation to the current crop of standards out there to get them finally changed in relation to taking the references off from 2201 to bring it in line with the new AS/NZS 62676 series. And John Fleming notified me about 15 minutes ago that should be adopted within the next month and sorted out. So that's the first step for the RTOs to start upgrading the training requirements to fall in line with the new scenarios. How do we ensure that companies are being employed or specify? Okay, the question basically is that how do you ensure that the people that you're employing or people that you're using to specify systems are actually understand the requirements of the new standards? It's a bit of buyer beware in essence. You need to be familiar with the standards yourself, and then it's really questioning techniques during whatever meetings or interviews you have, particularly if you award a tender, for instance, to make sure the companies that are responding to the tenders are actually compliant with the understanding of the new standards and requirements contained therein. Unfortunately, there is no requirement nationally for continual professional development to be completed on either technology or education within our industry. So there's a big hole there. So it really falls back to the consultants or the clients understanding that there is a hole within that area with the industry, and then adequately applying the right methodology to ensure they're hiring people of the right sort of understanding. So as I said, the training is a long way that goes to this. Is there any training available for companies? Yes, I've been training organizations, both stakeholder and security, high-end security organizations for well over a decade. So the sort of things that we do in training stakeholders to give them an insight not only to the technology and the backgrounds of the technology, but also to understanding how tenders are responded to and give them the tools necessary to be able to identify what the levels of understanding is within the persons responding to relevant tenders. There are a lot of smaller one-man band companies. How can we ensure they are adhering to standards, as the ones who are doing the right thing are being undercut by these smaller guys who don't adhere to it? Yes, major problem with the industry. There's a major problem both of licensed and unlicensed people floating around. So again, it really comes down to the customer or the consultant who's handling the relevant installation having a sufficient knowledge of the standards so they can ask the relevant questions to test the understanding of these companies, not only from a point of view of testing and understanding, but also having the level of detail contained within the documentation that's going out that specifies the operational requirement for these systems as a whole down to the nth degree, not only from the imaging aspect, but from mounting, communications, electrical. Documentation's a massive problem. Pre-testing, testing, the level of detail within the specification these days, or your tender documents, needs to be very concise. So again, it comes down to understanding the limitations of your particular knowledge and having someone within your organization that can be trained up to act as a champion within the organization, but also someone who's got an understanding when it comes to what people need to know. So when you are employing people, you need to be able to test their knowledge. Unfortunately, if you're waiting for the regulators to be able to put systems in place to ensure that happens, I'll be dead long and buried before anything like that's likely to happen. And I'd suggest that's a problem across the country. So as I said, training is the key, but training to a level that stakeholders understand and putting systems in place that allow the verification of levels of understanding and also compliance, so there is no wiggle room in the specifications, is absolutely critical. Okay, with that in play, guys, I don't have any more questions here. As I said, you're more than welcome to contact me through ASIAL. If you need to do additional training or whatever, we bounce all over the country and train people from Queensland through to Perth, so there's no issue with that. And if you need additional information in any way, just give me a call. ASIAL can provide my number. So with that, I'd like to thank you for your attendance and hope we catch up in the future. Thank you very much.